Welcome to Vision Plus and welcome to this senior for mathematics on complex numbers. We are now on example 5 and a modulus of a complex number. This is going to be our last example. So if you have questions, please send them and we shall be able to respond to them. Example 5 says that we are given two complex numbers and the asking part A is find the magnitude of Z1 plus Z2. You are free to pause the video and try it out. The magnitude of Z1 plus Z2. Now the first step is let's first get the value of Z1 plus Z2, which is the same as we substitute for Z1, which is 4 out of 5i plus 2, but we are adding it to Z2. Z2 is 2 out of 7i minus 3. Yes, the numbers can be fraction, can be decimal. So we just need to follow the principles and the laws that we use in addition of complex numbers. We say that we add the real numbers together and the imaginary numbers together. So the order does not matter. Let me begin with the imaginary parts together. That is 4i out of 5 plus this is also an imaginary part, that is 2 out of 7i. And then I proceed now to the real parts. 2 is positive, so I will add 2, but 3 is negative, I will subtract 3. And then you just add the fractions. Remember, because here we can just factor out, I because it is common, so that we have 4 out of 5 plus 2 out of 7. Then I attach I. And then here, what is positive 2 minus 3? That is simply negative 1. Now our focus is here now. How do we solve this? Here we use a method of, you can get the LCM of 5 and 7, and then you do your processes. But there is no mark for that. Yeah, there's no mark for that. It will take you much more steps than this. So but here you can just press the calculator. 5 divided by 4, or you open the brackets, then you say 4, actually it is 4 divided by 5 plus 2 divided by 7. Then you change it to fraction. I'm getting 38 out of 35, which is correct because the LCM of 5 and 7 is 35. I then minus 1. So this is the value of Z1 plus Z2. How about the magnitude now? If you are going to magnitude, first get the value of x. X is the real part which does not have I, which in this case is negative 1. How about y? Y is the coefficient of I, which is 38 out of 35. Then you say now, therefore, the magnitude of Z1 plus Z2 equals to the square root of x squared plus y squared, the under root. Then you substitute for Z1 and Z2. This gives us here that Z1 plus Z2 magnitude gives us square root of, what is x? X is negative 1, it could be a negative 1, but we are squaring it plus y. What is y? Y is 38 out of 35. Y is 38 out of 35 by squared. Then you proceed. If you look at that number, it is bulky. And do not stress yourself. The calculator is allowed for use in exam. So to make your steps easier, just say 38 divided by 35 and press equal sign. That is the decimal representation of 38 out of 35. But you are squaring it, so you just press square and press equal sign. It's giving me a very big number. It is small. It is 1.178. In your calculator, you should be able to have the same decimal because squaring it. And then you add it to what is negative 1 square. That is positive 1. So you simply add 1 here. So here I'm getting 2 point. It is still under square root. I've not taken the square root. It's 2.1788. You round to 4 dp. Now that is the value. And just to confirm it, normally raise your calculations twice so that you are sure. 38 divided by 35 square plus 1. Yes. And then from here now you take the square root. What is the square root of 2? 2.1788 square root. It is like 1.4761 units. I've rounded to 4 decimal places. So this is the solution for Z1 plus Z2 magnitude, or the size of Z1 plus Z2. Now let's go to part B. Part B is magnitude of Z2 minus Z1. So the first thing here we need to do is, what is Z2 minus Z1? Let's first get that value. So what is Z2? Z2 is 2 out of 7i minus 3. But we are subtracting Z1 since there are two terms. We open the brackets. And Z1 is 4 out of 5i plus 2. And then you proceed and say this gives us a 2 out of 7i. I'm keeping it the same minus 3. Now my focus is here. We have said that there is a negative 1 here. Negative 1 times 4 out of 5. It is simply negative 4 out of 5. And then I there. Negative 1 times 2, that is simply negative 2. And then you collect the like terms. This gives us a 2 out of 7i. Then you bring the other imaginary part here, which is minus 4 out of 5i. And then you put 3, which is negative 3 minus 2. And then, yeah, remember here you can factor out I. So that here you are left with 2 out of 7 minus 4 out of 5. I factored out I. Negative 3 minus 2, that is simply negative 5. And then you press your calculator. You open the bracket, you say 2 divided by 7. Close the bracket. Then minus. Open the bracket again. 4 divided by 5. Close the bracket. It is giving me negative 0.514. Change the fraction. Shift and ABC is negative 18 out of 35. Negative 18 out of 35i minus 5 is 5. And this is true. Why? The LCM of 7 and 5 is 35. And then you do your manipulation of fractions. So this is Z1, this is Z2 minus Z1. Here now implies that here we have X is the real part, we do not have I, it is negative 5. Y is the real part of the imaginary side, is a real number, which is negative 18 out of 35. Then you say therefore now Z2 minus Z1 magnitude gives us, remember the formula, X squared plus Y squared under root. This gives us here, what is X? X is negative 5 plus what is Y? Negative 18 out of 35. Don't forget that we are squaring it. Then you come back again. Remember, this number is going to be positive if you are squaring any number. So you open the bracket, you say negative 18 plus, no, divide by, negative 18 divided by 35 by the squared. Yes, I'm getting 0.226. Remember, this is negative 5 squared here as well. Negative 5 squared is 25. So I just add here plus 25. Yeah, I'm getting 25 point. Yeah, I'm getting square root of 25.2645 to 645 to 4 decimal places. Then you press the square root of that number, and the square root of 25.26 is simply the same as 5.0264 units. So this is the magnitude of the complex number Z2 minus Z1. And finally, we're going to part C, which says finding the magnitude of Z1, Z2. So part C, magnitude of Z1, Z2. It means here we need to first start by finding Z1 times Z2, which is simply the multiplication of the two given complex numbers. What is Z1? Since we are multiplying, we put the terms in the bracket. We have 4 out of 5 I plus 2, but we are multiplying it by 2 out of 7i minus 3. Here, you need to be close to your calculator. I have mine here. Now, what is 4 out of 5i times 2 out of 7i? If you're multiplying two numbers or two fractions, you simply multiply the numerators together and the denominators together. So, 4 times 2, that is 8. 5 times 7, that is 35. Yes. Now remember I times I, that is I squared. And again, this first term is going to multiply the second term in the second bracket. So 4 out of 5i times negative 3. This is the same as 4 times negative 3, that is negative 12 out of 5, then I. Now this term has multiplied the two terms. Then you come to take 2 times 2 out of 7i, it is simply 2 times 2, that is simply 4 out of 7i. 2 times negative 3, that is negative 6. And then we collect the like terms. Here we are going to have 8 out of 35, but I squared is the same as negative 1. Very important property. And then we subtract away minus. We are subtracting away 12i out of 5. We are adding 4i out of 7, and then minus 6. This here it is. Now this number is going to become negative. So I'm going to begin collecting the like terms. Anyway, let me go step by step. This gives us a negative 8 out of 35 minus 12i out of 5 plus 4i out of 7 minus 6. Let me start by collecting the imaginary parts together. That means here this one is negative. So here we'll have here negative 12i out of 5 plus 4i out of 7. Then I proceed by adding the real parts. This number is negative 8 out of 35, and then minus 6. Here I can factor out I as we did in the previous examples. So I'm still going with Z1, Z2 here, which I'm going to put. Now I will open a bracket and have there negative 12 out of 5 plus 4 out of 7, and I'll factor out I. And then minus, I still have that side, minus 8 out of 35 minus 6. Now here, what is negative 12 out of 5 plus 4 out of 7? Here's the calculator. Negative 12 divided by 5, close, but we're adding it to open bracket 4 divided by 7. I'm getting negative 64, negative 64 out of 35. But here you can just use additional fractions. Get the LCM and do what you are comfortable with. Now let me confirm this. Negative 12 divided by 5 plus 4 divided by 7. Yes, negative 64 out of 35 I. Then here we have negative 8 out of 35 minus 6. Let's come and say negative 8 divided by 35 minus 6 should be a negative number, bigger. This gives us here negative 218 out of 35. But here you could subtract just the normal way. But remember both are negative. You find the LCM. So let me confirm again. Negative 8 divided by 35 minus 6. Then you change the fractions. Negative 218 out of 35. So this is the product of Z1 and Z2. Remember the numbers of multiplication that we did, they were all linear. They were all numbers. We do not have fractions, but this is how you can solve fractions. This is how you solve fractions. So after getting this, then you deduce what is x. X is the real part, which is negative 218 out of 35. Here you don't need to give up. You must do all the steps. Y is negative 64 out of 35. Some of you, when you reach here, you begin to get confused. No, just follow your principles slowly. After this now, then you say magnitude of Z1 Z2 is going to be the same as x squared plus y squared, but there is under root here. This means that here we're going to have, what is x? X is negative 218 out of 35, but remember to square it, plus what is y? Y is negative 64 out of 35, don't forget to square it. And then from here, we just square. Now, don't waste your time writing bulky numbers. The calculator can do that for you. So let me start by saying, I have negative 218 divided by 35, close the bracket, squared. I have 38.7 something. Then I'm going to add it plus, open the bracket, negative 64 divided by 35, close the bracket, squared. It's giving me 42. And if you're pressing, the answer should also be 42.1388. This is just, it is still under root. So let me confirm, 218 divided by 35 squared plus 64 divided by 35 squared, yes, 42. And then you get the square root here of 42. 42.1388. I'm getting 6.4914 units. So this is the magnitude of the complex number Z1 times Z2.